Okay, let's solve absolute value of x less than 10. Again, the thing to do is just plug in values of x to see what works. X equals 8 works, x equals 9 works, x equals 9.9 works, but x equals 10 doesn't. We could run the same experiment for the negative values, and I think you'd see that the values of x that work are described in this number line diagram. So the numbers between negative 10 and 10, excluding the two endpoints. In interval notation, we'll write parenthesis negative 10 comma 10 parenthesis. And then we could write this as x greater than negative 10 and x less than 10. The nicest absolute value inequalities are those when you have just a variable and nothing else inside the absolute value, such as one of these. So absolute value of a variable is, and then some inequality symbol, and then a number. That's the best kind. But what if you have something more complicated inside the absolute value? What if you had, for example, absolute value of 6x plus 3 is less than or equal to 27? Well, the nicest thing to do, so you don't have to deal with too many different thoughts all at once, is to substitute a new variable, let's call it u, to be the contents that's inside the absolute value. And I'm using this word inside very carefully. It's the stuff inside the absolute value, but not including the absolute value symbol itself. So in other words, like in the example we have here, if we did this, if we said u is equal to 6x plus 3, then absolute value of 6x plus 3 less than or equal to 27 would become absolute value of u is less than or equal to 27. Let's do this carefully on the next slide with some color coding. So the question here is absolute value of 6x plus 3, close absolute value less than or equal to 27. We're going to substitute u is 6x plus 3. So u is really going to be just the stuff that is inside the absolute value. Okay, just the stuff inside. You'll notice that in this blue box here, with the yellow highlighting, there is no absolute value symbol written. The absolute value symbols just tell us where to look. They become the limit of what we're saying u is going to be. So then absolute value of 6x plus 3, just the 6x plus 3 is highlighted in yellow. Close absolute value, not in yellow, less than or equal to 27 is going to become absolute value of u in yellow, close absolute value, less than or equal to 27. Okay, so everything here in yellow is equal. First of all, u is equal to 6x plus 3 because that's how we defined u. So we'll do that. In starting our answer, u equals 6x plus 3, we end up with the problem absolute value of u is less than or equal to 27. That's that nice style problem, the absolute value inequality where all you have inside the absolute value symbol is just the variable. This was by design because we said all the stuff that was in the absolute value would just be called a new variable. Now we do the thing of exploring what values of u are going to work. And u equals 26, yeah, that's good. U equals 27 works. U equals 28 doesn't. Right? So just by trying to plug in 28 for u, take absolute value of 28 and you'd have 28. And is 28 less than or equal to 27? No, that's not true. So here's a picture on a number line of what values of u work. Yeah, so from negative, we didn't check the negatives, but I think I was just trying to save some space on the slide. So negative 27 to 27, inclusive, and all the numbers in between. Okay, so in interval notation, we could write bracket negative 27 comma 27. And then based on that, we could write u is greater than or equal to negative 27, and u has to be less than or equal to 27. So it's an and here because both things have to be true. Okay, that's what and is trying to get at, right? So both u must be both bigger than or equal to negative 27 and must also be less than or equal to 27. Now we're not done. See, the thing is the original question didn't talk about u, so we just need to now replace. Remember at the beginning, u was what we substituted for 6x plus 3. So now this u, now that we'd solved for u here and there, we'll replace that with 6x plus 3. Then subtract 3 on both sides of both inequalities. Be careful. Notice there's a negative 30 here. This is not a negative 30 here. This is a 24. Now take both inequalities and divide by 6 on both sides. You have x is greater than or equal to negative 5 and x is less than or equal to 4. The interval notation for this would be bracket negative 5 comma 4 bracket. And then in a number line diagram for x, not for u, but for x now would be negative 5 to 4, including the endpoints and then filling in between. Let's try another one of these. Okay, we'll solve absolute value of 4x plus 1, close absolute value, is greater than 9. To start, let's let u be the stuff that's inside the absolute value. Okay, so u is going to be 4x plus 1 alone. Notice in defining u, there's no absolute values written. But then that means the original problem is going to turn into absolute value of u is greater than 9. Okay, let's explore values of u that work. U equals 8. No, that doesn't work. U equals 9? That doesn't work, but it almost did. U equals 9.1? Yeah, that works. U equals 9.1 works, U equals 10 works, and so on. We can apply the same idea back to the negative values of U. We would get a number line diagram that looks like this. Here it is in interval notation. Yeah, parenthesis negative infinity comma negative 9, parenthesis union symbol, parenthesis 9 comma infinity parenthesis. It's perhaps very helpful to write in this interval notation right now because it's that union symbol that's going to become the word or. So either you can be smaller than negative 9 or you can be bigger than 9. It's not possible for both to occur at the same time. So that's why it's the word or, not the word and. But now that we've solved for u, we're not done. We need to now replace in this line every u that we see with a 4x plus 1. So we'll have 4x plus 1 is less than negative 9 or 4x plus 1 greater than 9. Subtract 1 on both sides of both inequalities. We'll have 4x is less than negative 10 or 4x is greater than 8. Now divide by positive 4 on both sides of both inequalities, and we'll get x is less than negative 10 fourths, which will reduce to negative 5 halves, or x is greater than 2. Here it is in interval notation. Parenthesis negative infinity, comma negative 5 halves, parenthesis union, parenthesis 2, comma infinity parenthesis, and then here's a number line diagram for x. Again, up here there's a number line diagram for u. Look how balanced it is with a plus 9 and a minus 9, and then our number line diagram for x is a little imbalanced with a number 2 and a number negative 5 over 2.